Hello everyone, and welcome to CodeSprout's Fundamentals of JavaScript tutorial series. In this video, we will be going over control flow, a concept that can make your programs more dynamic and interactive. Let's get started. Before we begin this lesson, the team at CodeSprout is excited to announce a partnership with Tutorial, a platform specializing in expanding access to learning and empowering the next generation of explorers and innovators. You can learn more about Tutorial at tutorialtoken.com. Let's get back to our JavaScript lesson. In this tutorial, we will be covering the following concepts: an introduction to control flow, if statements, else and else if statements, switch statements, loops, and finally, we will be using control flow in action. So what do we mean when we use the phrase control flow? Control flow is one of the most fundamental concepts in programming. It refers to the order in which individual statements, instructions, or function calls are executed or evaluated in a program. In JavaScript, as in most programming languages, code is executed from top to bottom, line by line. However, there are various control structures that will allow you to alter this flow based on decisions, repeated blocks of code, and handling errors. Without control flow, your code would simply execute from top to bottom without any ability to make decisions based on conditions, repeat actions multiple times, handle unexpected situations or errors, and skip certain parts of the code when needed. It's important to note that control flow transforms your code from a static list of instructions to a dynamic program that can respond to different inputs and situations. The main types of control flows in JavaScript are conditional statements, loops, jump statements, and error handling. The first control flow concept we will cover are if statements. The if statement is one of the most fundamental control flow structures in JavaScript. It allows your code to make decisions and execute different blocks of code based on whether a specified condition evaluates to true or false. The condition is an expression that evaluates to either true or false. If the condition is true, the code block inside the curly braces will be executed. If the condition evaluates false, the code block will be skipped. Here's a quick example. We have a number variable called temperature which is set to 28. And then we have an if statement with the condition that if the temperature is greater than 25, our console will print the statement, it's a hot day. And given that the temperature is 28, this condition would be satisfied and true, so our console would print out, it's a hot day. We can use the same comparison and logical operators that we covered in the previous tutorial. And we can even build on these if statements to create blocks of code that can execute multiple tasks. We will now cover else and else if statements. In the previous slide, we learned about if statements, which allow your code to make decisions based on conditions. However, often you'll want to execute different code blocks depending on whether a condition is true or false, or handle multiple different conditions. This is where else and else if statements come in. The else statement allows you to specify a block of code that will be executed if the condition in this if statement evaluates to false and there are no other suitable statements that would make the condition true. The else if statement will work similarly to the if statement in the sense that it will run condition is true, but only after the if statement, which will take priority. A good example of else and else if statements can be through this grading system program. This grading system program has an initial number variable called score, which is set equal to 85. Following that, we have an if statement that evaluates if the score is greater than or equal to 90, and then our grade variable will then be changed to an A. Following that, we have three else if statements that evaluate if our score is greater than or equal to 80, 70, or 60. And based on these conditions, whichever one is satisfied first, that would be the grade that we are given. For this example, since our score is 85, the if statement condition would not be satisfied. And so our program would go to the next else if statement. The first else if statement states that our score is greater than or equal to 80, which is a satisfied condition. And so if we print our grade variable through the console, we'll get that our grade is B. We will now cover switch statements. A switch statement is a control flow mechanism that evaluates an expression matching the expression's value against a series of cases and executes the associated code block when a match is found. It provides a cleaner alternative to a long series of if and else if statements when comparing a single variable against multiple values. Here's how it works. The switch statement evaluates the expression once. It compares the result of the expression with the values of each case. If there's a match, the associated block of code is then executed. The break statement exits the switch block and stops the execution of more case testing. The default clause is optional and specifies code to run if none of the other cases match, similar to the else statement. In this example right here, we have a number variable called day, which is set to 3. And what this program would usually do is based on what the day variable is set to, whether it's 1, 2, 3, all the way up until 7, marking each of the days in a week, it will then evaluate what day specifically it is and return the value as a string. As you can see here, since day equals 3, we'll evaluate condition 3, or case 3, where we have the day name variable equal to Wednesday. And so, when we print this in our console after all the cases are done, we are given that the day is Wednesday. The final concept that we will be covering in this tutorial are loops. Loops allow us to execute a block of code repeatedly, which is essential for tasks like processing arrays, iterating through data, or performing an action multiple times. The three main types of loops are for loops, while loops, and do while loops. For loops allow your code to be executed repeatedly based on a condition. It's particularly useful when you know in advance how many times you'd want to run or execute a block of code. For all three of these coding examples here, we simply have a variable I which is equal to 1. And through the loops, we will print the values 1, 2, 3, 4, and 5, all through a simple single console.log statement. And we can do so by defining what our I variable is, the initial condition that needs to be satisfied to false for our code to stop looping, and then an iteration mechanism that will allow our code to reach that condition through however many iterations it takes to do so, which in this case would be 5. While loops execute a block of code as long as a specified condition evaluates to true. It's much simpler than a for loop in terms of syntax, but can be just as powerful. As you can see here, we are declaring the variable outside of the loop and giving it an initial value, and then within the loop, we are including an iteration command, or any kind of command usually, that will allow us to reach our condition. If our condition is never met, then our loops are simply going to loop forever, which will cause errors when we run our programs. Finally, we have do while loops. A do while loop is similar to a while loop, but with one key difference. The code block is executed at least once before the condition is evaluated. This guarantees that the loop body runs at least once, even if the condition is initially false. In this coding exercise, we'll simply use a number variable called loop count, which will take on the user's input. The user will input how many times our code will loop, and every time our code loops, we'll print out a string statement through the use of if and else if statements for the console to make an initial observation regarding the size of the user's input, and output that into the console and repeat the process until the number of outputs matches the loop count variable's value. So firstly, we'll need to declare the user input for the loop count variable. To do so, we'll start by declaring the loop count variable and setting it equal to a prompt statement. Within the prompt, we want to specify that this will be how many times our program will loop, so we'll ask the user to enter the amount of times you would like the program to loop. Following this, we can begin implementing our actual loop statement. For this loop, I'll be using a for loop statement. And to do so, we can simply type for, followed by a set of two parentheses. Within the parentheses, we need an initial I value, which we will then set equal to 0, followed by the semicolon to mark that this is the end of our variable declaration. We will then want this program to run while I is less than or equal to the value of loop count, and after each iteration of the loop, we want the value of I to increase by 1 through the increment operator. We will then type in our else and if statements in the curly brackets. For our if statement, which will be our initial condition, we'll evaluate a response based on a loop count value that is going to be larger or greater than or equal to 30. And within this if statement, we can simply type console.log followed by the message that we would want to send to the user. Since anything larger than 30 is generally considered a larger number, of course it depends on the scope of what you're evaluating, but for this example, we'll say anything larger than 30 is a pretty large number. So our console will then print, wow, that is a large number. Looks like I will need to loop quite a few times, followed by the semicolon. We can then reuse this entire logic for an else if statement. And the else if statement will evaluate the value if the loop count is less than or equal to 29, and then we'll simply use two of the and icons to signify an additional condition, which will simply state that we'd still want loop count to be greater than or equal to 10 for this condition to run. And for the print message in this condition, we can say, this is not a very large number. I should have no problem looping. And finally, we can use this logic for an else statement. And for an else statement, we do not need any conditions to run it. And the else statement will simply evaluate that since the value would need to be greater than 30 for the if statement to run, greater than or equal to 30 for the if statement to run, and for the else if statement to run, the value would need to be between 29 and 10 since we use the and operator, then the else statement would essentially evaluate any number that is less than 10. And so, our else statement can simply state, looks like you picked a pretty small number. I should have no problem at all looping. And now if we run this program, we'll simply be prompted to enter the user's input, and based on the input, our program will print out this message X amount of times. If for some reason you aren't able to get your code to compile, that could mainly be due to the placement of these curly brackets. You need to close each else and else if statement with curly brackets, as well as the entire for loop in general. So let's go ahead and run this program. We're asked to enter the amount of times you would like our program to loop. So I'll type in 4. And if you look carefully here, you'll notice that our program is actually looping through 5 times and printing out 5 messages. And that is because our I variable is starting at 0 instead of 1. Now if we run it with the I variable starting at 1, and we ask for it to loop 4 times, we can see that we are now getting our program to loop 4 times. Let's now pick a number like 15 and see if we can trigger the else if command. So if we pick 15, as you can see, our program is now printing. This is not a very large number. I should have no problem looping 15 times, as it is being fulfilled by the else if statement, and then the program is iterating from 1 to 15, which would then make the entire loop statement false and exit us out. Now let's go ahead and pick a large number, like 50. As you can see, our program is detecting that, wow, that is a large number. Looks like I'll need to loop quite a few times, and our program loops quite a few times. 50 to be exact. Congratulations! You have now completed CodeSprout's control flow tutorial. You have just learned an exciting new concept that you will see as a core topic throughout your programming journey. You can now make cool and interactive programs like the one from our coding example. We implore you to read through CodeSprout's lesson section on control flow to cover these concepts in more detail, and try out these control flow mechanisms yourself in CodeSprout's JavaScript playground. We would once again like to thank the team at Tutorial for helping us make coding accessible and engaging for everyone. See you in the next lesson.